For partial fractions, there are two things that we need to check. First, we need to check if the algebraic fraction given, if it's a proper or improper. And the second one is to check the denominator, if it's linear, if it's repeated linear, or if it's irreducible quadratic factor. Okay, let's check for the degree first. So the numerator, quite clearly, highest power is 1, so this is of degree 1. Denominator, if you take x times x, it will give you x squared, and of course some other terms, but the highest power is 2, so this is degree 2. Right, so this is this is a proper fraction. This is a proper fraction. Right, because the degree of the numerator is less than the degree of the denominator. Right, the second one we need to check is, let's look at your denominator. So your denominator is made up of two linear factors. Right, so what are the rules? So we can let x plus 3 for two linear factors. Alright, the first partial fraction will be a constant a over your first linear factor x minus 2 plus, it's always plus, okay, it's always plus b over the second linear factor. Right, then we combine them. There's one easy way to remember to know what to multiply your a with. You just have to close up x minus 2, because the denominator for the first partial fraction is x minus 2, so you close up x minus 2. So when you close up x minus 2, then you're left with x minus 4. Then you know that I need to take a times x minus 4. Alright, likewise you can do it the same. You can just close up x minus 4 for the second partial fraction. Right, so then we know that if you close up x minus 4 at the denominator, what is left is x minus 2, so you have to multiply b with bracket x minus 2. Okay, so a of x minus 4 right, so this become your identity. So we're going to use substitution method. Substitution method is easiest to use for such identity. Of course, sometimes that if you can't get the answer using substitution, then you will have to use compare coefficient. So we're going to let x equals to 4 so that you can eliminate a. All right. Okay, so now we're going to put everything back into a partial fraction. So therefore, the partial fractions is partial fractions are, sorry. Okay, so a will be negative 5 over 2, then divide by x minus 2, and b will be 7 over 2, then divide by x minus 4. All right, you cannot leave answer as in this form. It's not simplified. It's considered not simplified. All right, so how do we simplify it further? There's one trick here that I can teach you. You just have to multiply the numerator with 2, denominator with 2. Okay, how do you know that you need to multiply with 2? You just look at the denominator of the numerator. Negative 5 over 2. So the denominator is 2, right? So just times 2. Likewise, for your 7 over 2, denominator is 2. You just multiply by 2. Multiply by 2. So what do you end up with? You end up with negative 5. Then over 2 bracket x minus 2 plus 7 over 2 bracket x minus 4. Okay, so these two are our partial fractions. 7 over 2 times 2 will give you 7. If you're not too sure, you can write 2 as 2 over 1. Right, so you just multiply numerator, which is 7 times 2, 14. Denominator is 2, so 14 divided by 2 gives you 7. Right, let's look at the second question. Right, let's check for the degree. Right, so numerator is degree 1. and your denominator is degree 3, right? So this is a proper fraction. Okay, it's a proper fraction because your numerator, the degree of the numerator is less than the degree of the denominator. So proper fraction. So what they're given is a proper fraction. Okay, the next thing very important is to check for your denominator. All right, let's look at the denominator. Right, x squared minus 4. So if you have x squared minus 4, this one can be written as x squared minus 2 squared. And this you can be factorized further into x plus 2 and x minus 2. Okay, here I need to remind all of you again that x squared minus 4, right, is not the same as x squared plus 4. Alright, x squared minus 4 can be factorized into x plus 2 and x minus 2. But x squared plus 4 is called an irreducible quadratic factor. So please remember that. Okay, irreducible quadratic meaning the x squared plus 4, it cannot be factorized anymore. It is just x squared plus 4, that's it. Okay, right, but x squared minus 4, right, you can factorize it into x plus 2 and x minus 2 using the formula, using your algebraic identity. Okay, so it's very important that you see the difference between these two. Right, so our algebraic fraction will become okay, and then the next step is that you can combine your x minus 2 with the x minus 2. So this x minus 2 and x minus 2, combine them to form a repeated linear factor. Okay, this will become a repeated linear factor. Alright, so do you remember the formula to find for repeated linear when the denominator is a repeated linear factor? Do you remember how to express it as partial fractions? Alright, so let's write it at the linear factor first and then the repeated factor. I mean, you can leave it as, if you want, you can leave the repeated linear first and then followed by the linear. It doesn't matter. Okay. So, alright, never mind. We'll just leave it as, otherwise some of you will be thinking why I do that. So I'm just going to let right. So for this repeated linear, it will be a over x minus 2 plus b over x minus 2 squared. Okay? And for this linear itself, x plus 2 will just be a c, a constant c, over x plus 2. Alright? Then the next step is that we have to combine them into one huge fraction. Right, then the common denominator will be x minus 2 squared followed by x plus 2. So you can use the cover-up method that we learned just now. If you look at your first partial fraction, you cover up x minus 2. Now you have x minus 2 squared, meaning you have x minus 2 and another x minus 2, right? So if you cover up one of them, so you're only left with one x minus 2 and also the other linear factor x plus 2. So hence for your constant a, you need to multiply by x minus 2, also x plus 2. Okay, I'm going to erase all this because I don't think I have space. Alright, so likewise for your, okay, the second partial fraction, if you look at the second partial fraction, the denominator is x minus 2 squared, right? So you just cover this up. So if you cover that up, it left only x plus 2. So you multiply your b with x plus 2. Okay, then the last term will be, if you cover up this guy here, so you're left only this, so you multiply c with the x minus 2 squared. Alright, so if you may not understand the first time, quite honestly, like if you understand the first time I teach them, my explanation will be very clear, that's very good. But if you don't get it, please look at it again one or two times more, and then you'll be able to understand. Right, so the next step then is to compare your numerator, the numerator of the left side with the numerator on the the right side with the left side. And here I would advise you to use substitution. Okay, it's easier to use substitution here. So let x equals to 2, then my a will be gone and my c will be gone, so I can find my b. So b will be 5 over 4. Alright, so I can, after finding the values of b, I can let x to be equals to negative 2. Right, if I let x to be negative 2 here, then I can eliminate my a and b, so I can find my c. So that gives me negative 4 squared, negative 1. So that will be 16c equals to 1, c equals to 1 over 16. Alright, okay, so I found the values of b and values of c. Then I can use any other values of x except for 2 and negative 2. Because you already use it, you already use x equals to 2, you already use x equals to negative 2. So you're not going to reuse them because it will not help you to get any more new information. So we're going to let x equals to 0. Right, so a will be negative 2, 2, b will be 5 over 4, c will be, okay, I found c to be 1 over 16 already, so I can just put it back. And then I let it to be 0, so that will be negative 2 to the power of 2, and give me 3. Okay, so let's try to simplify further. That will be negative 4a. Okay, sorry, I don't have a calculator. 5 over 2 plus 1 over 4. Then 11 over 4. 11 over 4. Alright, so negative 4a will be 3 minus 11 over 4. And that will gives you 1/4. So a will be negative 1 over 16. Alright, so we found all our values of a, b, and c. Right, so now we can put them into our partial fractions. Alright. Okay, let me see where I can put them, because it's like I don't really have a space for it. Okay, never mind. I will try to put it here. Okay, never mind. I think I'll do it at the next slides. Right, so what we have here, we have found the values of a to be negative 1 over 16, b to be 5 over 4, and c to be 1 over 16. So the partial fractions are written there. Right, so we're going to use the same trick that I taught you just now. So if you look at the first one, you can just multiply by 16 here. Alright, I purposely make it 16 over 1 here, just in case that some of you may not understand why is it negative 1 over 16 times 16 gives you negative 1. And here I multiply with 4 over 1 at the numerator, also at the denominator. Here I multiply with 16 over 1. Alright, okay, so what do I get? Right, so I will get negative 1. Now the negative at the numerator, you can actually just put it in the middle. So 1 over 16 bracket x minus 2. Then 5 over 4 bracket x minus 2 squared. And then 1 over 16 bracket x plus 2. So that will be our answer. Usually we have to check if this is a proper or improper fraction. So let's check for the degree of the numerator. Yes, this is x to the power 1. So this one is degree 1. And if you look at the denominator, that will give you x cubed plus some other terms, so that will be degree 3. Yes, this is a proper fraction, so we can actually apply all the rules we've learned so far to express it into partial fractions. So the next thing is that let's look at your denominator. So if you look at the denominator, it comprises of a linear factor. X minus 2 is a linear factor. So this one is a linear factor. And then the x squared plus 4. Okay. Do not confuse with the x squared minus 4 that I mentioned earlier on. X squared plus 4 is a irreducible quadratic factor. All right, so how do we express it as partial fraction? So we're going to let all right, so for the linear factor, it will be a over x minus 2. Then for your irreducible quadratic factor will be bx plus c over x squared plus 4. So the next steps will be what we have been doing so far, combine them into one algebraic fraction. All right, and then you compare the numerator on the left, on the right with the numerator on the left. Okay, we're going to use substitution method as usual. I'm going to let x equals to 2. Right, because when I let x equals to 2, I will eliminate b and c, so I can find the value for a. All right, so the next step is that I can let x equals to 0, so that b times 0 give me 0, so I can find the values for c. I've already found the values of a to be 5 over 8, so you can put it into your identity. Okay, here you can easily use a calculator. Negative. Right, that will gives you 1/4. No, that will gives me negative 1/4, sorry. Because 3 minus 5 over 2 will be 1 over half. Half divided by, that's negative 1/4. Okay, negative 1/4. All right, so I found the values for A and for B. For C. I still need to find the values for B. Right, so I can just let x equals to 1. All right, I have 4 minus 25 over 8. 32 minus 25 is 7, right? I'll end up getting sorry, I don't have a calculator with me. I think you'll end up getting 7 over 8. And then you divide by 7 over 8 will be negative 1. So that will be negative 7 over 8. And then you can find the values of b, which is negative 7 over 8 plus 1/4. That will be negative 5 over 8. Alright, so we found all our values. Now we can put it back into our partial fractions. So therefore the partial fractions are 5 over 8 over x minus 2 plus negative 5 over 8 minus 1/4 over x squared plus 4. Okay, so we're going to use the same trick that I taught you just now. Right, if you look at the first partial fraction, look at the numerator, you just multiply by 8. Alright, and then you would end up getting 5 over 8 times 8 is 5 over 8 times 8 over 1. That gives you just 5. Right, remember to bracket the x minus 2. Okay, x minus 2, you have to bracket it. Right, the second term is a bit tricky. Second term is a bit tricky because you see that I don't have the same denominator. This guy is a 8, this guy is a 4. So we just multiply with the bigger number, which is 8. Okay, so I multiply with 8 at the numerator, 8 at the denominator. So it means that I have negative 5 over 8x times 8. So that gives you negative 5x. Then negative 1/4 times 8, that gives you negative 2. Alright, so it's a bit tricky here because can you see that I have negative 5x minus 2. So I am going to factorize the negative out. So this one, the last part here is a bit tricky. So if I factorize negative out, I'll get 5x plus 2. Okay, and then if I simplify further, okay, you need to take plus times minus. You cannot leave answer as plus and then with the minus there. No, you have to simplify it. Right. And so if you simplify it, your partial fraction will be 5 over 8 bracket x minus 2 minus 5x plus 2 over 8 bracket x squared plus 4. Let's check whether if this is a proper or improper fraction. This one is of degree 2, and this will give us 2x squared, and some other term, this is degree 2 also. So hence this one is an improper fraction, because we learned earlier on that if the degree of the numerator is the same or more than the degree of the denominator, then this would be an improper fraction. So for improper fractions, you cannot just jump into applying the rule straight away. Okay, you have to apply this thing called the long division. Right, so first thing first, let's do the long division. Alright, you have to expand your numerator to get 2x squared minus 5x. That will be our divisor. Multiply by 3 will give you 6x squared minus 15x. That will give me negative 6x plus 25. Alright, so I'm going to write my algebraic fractions. This will give me my quotient. This is my quotient, which is 3 plus my remainder. This one is my remainder, which is negative 6x plus 25. And this is my divisor. Alright, so which is the one that we have applied the rules? This one, because this will be proper. This is a proper fraction. Alright, so we just leave the quotient alone and we just apply the rules to this proper fraction. Okay, so negative 6x plus 25 over 2x squared minus 5x. Okay, factorize your denominator into x bracket 2x minus 5. Then if you look at it carefully, we have a linear factor which is x. So my first partial fraction will be a over x. I also have a linear factor which is 2x minus 5. So my second partial fraction will be b over 2x minus 5. Okay, likewise, combine them. So you see that it is actually not difficult for partial fractions. All right, just have to practice a few times and remember the formula. All right, so let's use substitution. I'm going to let x equals to 0 very easily so that I can eliminate my b. And then I'm going to just let x equals to 1. All right, so therefore, the partial fractions are okay, 3 minus 5 over x plus 4 over 2x minus 5. All right, so if you look at the questions, you're supposed to find the values of a, b, and c. So you cannot just put your answer, final answer is the partial fractions are so and so. You have to compare your partial fractions with what you're given in the questions and write down the values of a, which is 3, values of b. So therefore, a is 3, b is negative 5, and then c is 4. Okay, that will be your final answer. All right, let's check. Numerator is of degree 3. Denominator is of degree 2. Yes, so this is an improper fraction, so we have to apply long division to decompose it into a quotient plus a proper fractions. Another thing to watch out for is look at the denominator very carefully. If you look at the denominator, it is a quadratic. It is a quadratic polynomial. So for quadratic polynomial, some of you may just jump into applying your bx plus c. Right, before you jump into applying bx plus c, you have to ask yourself, is this quadratic polynomial a reducible or irreducible one? So this one here, clearly you can factorize it into 2x minus 1 and 2x plus 1. So hence this is a reducible one. This one can be factorized. Okay, so you have to be very careful with that. Right, so let's apply long division first. Okay, so I would have 12x squared. Then negative x plus x give me 0. So 12x squared minus 4. Then I can multiply with the 3. Give me 12x squared minus 3. Negative 4 plus 3. Negative 1. So therefore my after doing the long divisions, what do I get? I would end up getting quotient, which is my x plus 3, plus my remainder. This is my remainder, negative 1 over, this is my divisor. And my divisor, I can actually write it as 2x minus 1 and 2x plus 1. It's easier for me to apply the partial fraction rule. Alright, so this one definitely it's a proper fraction. So we're going to apply the partial fraction rules for that. We're going to let negative 1 both of them are linear factors, so it's just a over 2x minus 1 plus b over 2x plus 1. Okay, so it's the same steps again. Right, and you compare the numerator. Right, substitution method, I'm going to let x to be negative half so that I can eliminate my a. How do you get negative half? We just let this guy equals to 0. You let 2x plus 1 equals to 0. So 2x is equals to negative 1, x is equals to negative half. So a will be eliminated, so b will be 2 times negative half minus 1 equals to negative 1. Right, so you will end up getting net minus negative 2. So b will be negative 1 divided by negative 2 gives you half. Alright, then the next thing you can just let x equals to 0. So a will be 1. Put back your b, which is half, minus 1 plus half, negative half. Alright, okay, so now we have found the values of a and b. Now we can put everything back into our partial fractions. So therefore, the partial fractions are x plus 3 plus 2x minus 1. 2x minus 1 is my a. So my a is negative half. And then my b is half. Alright, so we use the same trick. Times 2 times 2. So we end up getting x plus 3, then minus times negative is negative. Half times 2 is 1, so 1 over 2 bracket 2x minus 1 plus 1 over 2 bracket 2x plus 1. Alright, but this is not the answer yet. We have to compare this one they have underlined, with what you're given in the questions. So from there, you can see that your a, x is equals to ax, so a is 1, b is 3, your c will be negative 1 over 2, negative half, and d will be half. Right, if you look at these algebraic fractions, we can clearly see that we have a linear factor here. Okay, this one is a linear factor. Right, however, this here, this is an irreducible quadratic factor. Irreducible quadratic factor. So do you recall, for irreducible quadratic factor, what should be the rules be? Yes, you should use bx plus c, and you should not just use b only. Right, so clearly this student has made a mistake. So how do we explain our answer? Right, we explain it this way. We say that x squared plus 2, since x squared plus 3 is an irreducible quadratic factor. Right, the partial fractions for 1 over x squared plus 3 should be bx plus c over x squared plus 3. and not b over x squared plus 3. Continue from what we have done in part 1. So part 2, now that we know 1 over x bracket x squared plus 3 can be decomposed into a over x plus bx plus c over x squared plus 3. Let's try to find the unknown ABC. Alright, so we're going to let x equals to 0, because if x is equal to 0, then we eliminate b and c straight away. So that gives us a equals to 1/3. Right, I think the next one is that I won't be using any more substitution. I think it's easier now to use compare coefficient of the similar terms, so I'm going to expand it. Right, so you observe that I don't have an x term on my right hand side. Right hand side there's only a constant term, so therefore cx is actually 0, so that make c equals to 0. And then also you can see that we don't have an x squared term on my right hand side, so therefore ax squared plus bx squared is equals to 0. A plus b equals to 0, so b is equals to negative a, which is equals to negative 1/3. Alright, so now we have find the values of a, b, c. We can put it into a partial fractions, so therefore the partial fractions are a, which is 1/3 over x, plus b, which is negative 1/3 x. C is 0. Alright, so we're going to use the same trick that we learned just now, times 3 times 3 times 3 times 3. So it will give us 1 over 3x. Okay, plus times negative is negative. That will give us x over 3 bracket x squared plus 3.